On the surface, the moon looks silent and empty. But deep near its southern craters, something extraordinary may be waiting in complete darkness. Imagine a Chinese spacecraft slowly descending through black space while giant shadows cover the surface below. Scientists believe these frozen regions may contain resources that could completely change humanity's future in space. China is not simply sending missions to plant a flag or repeat history. It is preparing for something permanent. Hidden beneath those ancient craters could be frozen water, valuable minerals, and the foundation for humanity's first base beyond Earth. That is why experts around the world are paying close attention. But the biggest question remains frighteningly simple. Why does China keep returning to the moon again and again? Most people believe moon missions are about prestige and national pride. However, China's strategy appears far more calculated. Every mission seems connected to a larger plan that has been unfolding quietly for years. Scientists now believe the real target is not the bright surface visible from Earth, but the permanently dark craters near the lunar South Pole. Those areas may contain billions of years of preserved ice. If that ice can be converted into oxygen and rocket fuel, the moon could become the first fueling station in space. Suddenly, this is not just about exploration anymore. It is about controlling the future gateway to Mars and the rest of the solar system. Unlike many nations that rushed toward dramatic astronaut landings, China followed a slower and more disciplined roadmap. First came orbiters, then landers, then sample return missions. Finally, preparations for a permanent lunar base began. The strategy resembles constructing a skyscraper. Engineers build the foundation first, strengthen the structure second, and only then complete the final design. In 2008, Chang'e 1 orbited the moon and created highly detailed maps of the surface. Later, Chang'e 2 improved those maps and identified safer landing zones for future missions. To the public, these missions appeared quiet and unexciting. Secretly, they were laying the groundwork for something enormous. Those early missions were never designed to impress television audiences. They were training exercises for a future that China believes will reshape civilization itself. Every map, landing test, and rock sample moved the country one step closer toward building humanity's first foothold beyond Earth. In 2013, China achieved something the world had not seen since the 1970s. Chang'e 3 successfully performed the first soft landing on the moon in nearly 40 years. For China, this was far more than a technological victory. It was proof that the country had entered a new era of space exploration. Attached to the lander was a small robotic rover called U2, meaning Jade Rabbit. As the rover rolled across the dusty gray surface, scientists expected it to confirm what earlier American Apollo missions had already discovered. Instead, U2 found something completely unexpected. The rover analyzed nearby volcanic rocks and detected mineral compositions unlike the Apollo samples collected decades earlier. The chemical patterns looked different, and the structure of the rocks suggested an entirely separate volcanic history. Scientists suddenly realized the moon was not one giant uniform sphere of dead rock. Different regions had formed during different periods and through completely different geological processes. That discovery changed the scientific understanding of the moon forever. Areas once considered boring and lifeless suddenly became scientifically priceless. If one unexplored region could rewrite decades of research, then scientists began asking an even bigger question. What secrets were still hidden inside the vast areas no spacecraft had ever reached before? The answer pushed China toward one of the hardest missions in modern space exploration. The moon always keeps the same side facing Earth because its rotation perfectly matches its orbit. That means the far side can never directly communicate with Earth. Any spacecraft landing there would immediately lose contact. No signals, no commands, no real-time control. For decades, scientists considered a far-side landing nearly impossible because one small error could destroy the entire mission. China solved this problem by launching a relay satellite before attempting the landing itself. The satellite positioned itself where it could constantly see both Earth and the hidden side of the moon, allowing signals to bounce back and forth across space. In 2019, Chang'e 4 became the first spacecraft in history to land on the far side of the moon. It touched down inside the enormous South Pole Aitken Basin, one of the largest impact craters in the entire solar system. Scientists believe this basin may expose material buried deep beneath the lunar surface since the moon first formed billions of years ago. Then came Chang'e 6. The spacecraft landed, collected samples, launched back into lunar orbit, docked successfully, and returned precious material to Earth. Those samples revealed volcanic activity lasted much longer than scientists previously believed. The moon's story had become stranger, deeper, and far more mysterious. But China still was not chasing its ultimate objective yet. The discoveries were extraordinary, but they were only opening moves in a larger strategy focused on the darkest craters near the South Pole, where scientists believed resources would reshape civilization. Everything China had accomplished so far was leading toward one terrifying and mysterious location, the lunar South Pole. Unlike the bright side of the moon visible from Earth, this region contains enormous craters buried in permanent darkness. Because the moon barely tilts on its axis, sunlight never reaches the bottom of some craters. Not for months, not for centuries. In some places, sunlight has not touched the ground for billions of years. Temperatures there fall below minus 200 degrees Celsius, colder than the surface of Pluto itself. Scientists describe these craters as giant natural freezers preserved since the birth of the solar system. And hidden inside that endless darkness may be the most valuable resource ever discovered beyond Earth frozen water ice. At first, water on the moon may not sound revolutionary, but in space exploration, water changes everything. Water can be separated into oxygen and hydrogen. Oxygen allows astronauts to breathe. Hydrogen becomes powerful rocket fuel capable of launching spacecraft deeper into the solar system. Right now, every kilogram of fuel must escape Earth's enormous gravity, making space missions unbelievably expensive. The moon changes that equation completely because its gravity is far weaker. If astronauts can mine ice from the lunar South Pole, future spacecraft could refuel there before traveling to Mars or beyond. The moon would stop being a distant destination and become humanity's first off-world supply station. Suddenly, this is no longer just a scientific mission. It becomes a race for strategic control over the future of space travel itself. That is where Chang'e 7 enters the story. This mission was specifically designed to investigate the permanently shadowed craters directly and confirm whether large amounts of frozen water truly exist beneath the surface. Traditional lunar rovers cannot survive in those conditions. Solar panels become useless without sunlight, and normal wheels struggle on steep, icy terrain. China responded with something completely different, a robotic probe capable of hopping into deep craters like a mechanical explorer jumping across another world. The robot carries instruments designed to detect water molecules, hydrogen deposits, and frozen material hidden underground. It can travel into places no previous rover could safely reach, and then send the information back to scientists waiting on Earth. If Chang'e 7 confirms major ice reserves, it could become one of the most important discoveries in the history of space exploration. Finding resources is only the beginning. China also wants to learn whether the moon can build itself. Chang'e 8 focuses on technologies called in situ resource utilization, meaning astronauts would use lunar materials instead of transporting everything from Earth. Engineers plan to test methods for turning lunar soil into solid construction bricks, extracting oxygen from rocks, and using robotic three-dimensional printers to create structures directly on the surface. These experiments could allow future astronauts to build landing pads, laboratories, protective shelters, and roads without constantly relying on supplies launched from Earth. China ultimately plans to connect these technologies into the International Lunar Research Station, a permanent lunar base featuring power systems, scientific laboratories, robotic construction equipment, and living habitats for astronauts. Several countries have already expressed interest in joining the project. The implications reach far beyond one country or one mission. The moon is no longer simply a place astronauts visit for a few days before returning home. It may become humanity's first permanent infrastructure hub beyond Earth, similar to how ancient ports once opened new trade routes across the oceans. Whoever builds sustainable infrastructure on the moon first could influence future Mars missions, deep space exploration, and the direction of human civilization for generations. The moon was never the final chapter of exploration. It was only the opening page, and now the question becomes impossible to ignore. If humans establish a permanent moon base by 2050, would you actually choose to live there? If you enjoyed this documentary, like the video, subscribe, and turn on notifications because the next great space race has only just begun.